я Данил Садырин, исследователь компании.
Hello, my name is Daniil Sidirin. I'm from CyberRock Analyst. I work with web security. Hello, my name is Andrei Sikorsky. I'm also from CyberRock. I work on incident development and incident investigation, and we will tell you about fileless web shells and how to detect them.
Web shell — это командная оболочка
A web shell is a special shell to control a server
командная оболочка для удаленного управления веб-сервером.
for remote control. And let's see how an attacker could implement the code remotely by using web applications. They can do it through the pre-uploaded file with the code using a specific language stored on a disk. But the problem here is that they use a file and it's easier to find. The code could be run through common injection or object injection. But the query could be detected by the WAF and the backend could be patched by the developer. You could have some changes in the initial code, in the source code, but it's easier to find when the version is updated. For example, some configs could be stored there, but it requires a special code. And it also requires unification of the database. And they can be found in global config files, as well as the files, the model files, but it requires high level of administration rights. They can also be hidden in web server process memory, and the advantage here is no need to use any file system or database. They can mask code execution requests as requests to a legitimate script. Here is that the backdoor works until web server will be terminated or refreshed. Or we will take look at Apache 2 and PHP language as an example. There was Zero Nights in 2018. They were speaking about ELF execution in Linux RAM, and there was a presentation of an approach to execute ELF files from memory using memfd create syscall. Memfd create was called using write-info/proc/self/mem from PHP interpreter, but it doesn't work for PHP by default. It's possible to implement this code for PHP Apache, but the study is pretty old and it does not. It's a bit old and it requests PHP uninitialized memory bug, but it's not fileless web shell. Furious. And the problem here is that it requires permission to edit php.ini and restart Apache 2. Another point is that many disable functions bypass POCs in public. And these POCs use binary bugs in PHP interpreter and to patch process memory in order to execute the system bypassing. This is a more general approach, but needs to find some fresh bugs in PHP. But PHP has quite a lot of history of bugs. PHP Tracker Bugs PHP has more than 81,000 trackers, and GitHub repository has more than 11,000 issues. Let's take a look at the bug number /80063. And the bug is all about the deletion of extra elements when object is resized. Object destructor method can be called in the middle of resizing, and there is no check that size of array is changed. Access elements in destruction. Destructor causes use after free. This is after-free bug can be used to get arbitrary memory read-write from PHP script. And the case when the size was 0 was fixed in bug #B0663. Similar bug is present in all other versions of PHP.
Окей, имея чтение и запись в память процесса, куда нам
adding in process memory, where do we put the shellcode in memory to be executed on every request? And to analyze, we will consider PHP lifecycle. PHP starts a little bit after Apache and runs sequential initialization in the memory. And every time a new request arrives to be handled, PHP will run a request startup step or reneat for every loaded model. It will override request startup func pointer in Zend module entry structure into the address of shellcode. We will have this shellcode. To do so, we will generate template for PHP expansion in C, and we will use our code, we will write our code using reneat function. We will just get the additional information from this function, and since in this shellcode functions and non-known addresses are used because it's placed on a server, we will leave some stubs in the code which will be filled later. Now we upload it to a PHP script to the server, and it reads proc self maps to get PHP executable base. It parses PHP executable elf headers and sections, then it searches for functions and gadgets for ROP chain, then it searches for shellcode Z string structure in heap, then it leaks PHP execute script code and calculates possible return addresses. Then it goes and searches for return addresses in stack memory, writes ROP chain into stack, and there is no need to stack the pivot. And when PHP script exits from Zend execute, chain does its work. Now the ROP chain itself, it sets write permissions to .txt memory segment for shellcode using mprotect. Then we copy shellcode from PHP heap to .txt memory. We set execution permissions to memory, override reneat function pointer into shellcode address, and call Zend timeout to clean exit from PHP. We run it several times to backdoor all the Apache processes, and then we remove the script. And this presented proof of concept for injecting a fileless web shell is suitable for any PHP configuration and requires minimal permissions. Thank you, Daniel. And Daniel has covered the main advantages of this technique, or this approach on covering this, especially for attackers who want to find the vulnerability. Just a few minutes on how we can try and find this vulnerability, at the injection of the process, how it goes into memory, and post-exploitation. For detecting, we'll use SOLDR. SOLDR is a system of orchestration of cycle control detection and response. It's a system of LDR, which is created by Solid Technology, and last year we decided that it will be open source. We created a website, we uploaded the source code. It has these images, it has the source code, you can go there and you can run it on your computer. Just a few slides on the SOLDR models. It's a cross-platform agent. Architecture is module, and each model has its own designation. If we're speaking about attacking web servers usually are Linux nodes, and Linux nodes are harder to monitor even now in multiple companies. And what we need for detecting is the standard setting, which will get the torrents of events We also need correlator. For that, we need Yara scanner. If we want to bring the server to the agent, if we want to expand some permissions, if we want to collect some artifacts, and maybe we want to react in some way. Now we go to the audit. If you audit rules, we will look for ptrace, because that's privileged access was granted. It's the presence of the third-party country, or maybe a debugging mode. Daniil mentioned that this can be used, and this code is placed in the RAM, and we will get just an anonymous file which will have the link to this part of the RAM. The second part of the rules is memfd.create and /create, and usually it registers events. So we will register events for the server. There are a lot of events, but among them we'll be able to find unique sequences with the access keys, and it will tell us that the memory was designated not for normal code, but for some third-party code. The same can go to osquery. They have different commands to run. If the code was uploaded, you can use Yara scanner via SODR. This is how it looks like. This is the interface. You can scan either the file or the RAM. You can use the pre-made policy in SODR, or you can create your own rules and run the scan. This is exactly what we did. We created our rules, we ran the scans, we got the detection, and it tells us that this in memory proc HTTP, we have a PVP shell web shop. And we can do it not necessarily manually, we can do it with triggers, and it can be triggered by different modules, by different events, all of them which we mentioned before. And it's better to scan the RAM and files regularly, because your company, your software can be backdoored, and only after a few months they will use it. Now a little bit about post-exploitation activity. There are audit rules for suspicious activity exec by web daemon user, then we will use suspicious file activity by web daemon user, and suspicious network activity by web server processes. And according to the first 2 points, we can find a lot of useful information. If the attack actually developed, then you'll be able to find the traces, because it's web server, it's web interaction, you'll be able to find these traces, and the internal connection, clearly you'll be able to use it.
Этот поток событий запускаем в коррелятор, коррелятор нормализует, пытается построить цепочки событий, исходя из тех правил, которые там есть.
Event turned into the correlator, and if it activated, we will get an alert. And here we can see this alert.
Получили вывод себе. Собственно, здесь используется язык XP.
We use XP language. It's not that widespread, but tomorrow, during the PhD, we'll have this community section. There will be presenters from the security expert community. These are very good guys who want to share their knowledge, who want to create great projects together, and they will speak about this XP code and how you can use this code and use it, for example, in SODR. Please join us and listen to us. And you also have workshop tomorrow. All our researches will be uploaded here. Research, proof of concept, the rules of detecting. Or you can find it at GitHub. And in the nearest future, we'll have a sprint. The participants will write correlation rules in the extraction and processing language, and develop tools for protecting against cyber attacks in one team. Unfortunately, we've run out of time, so we have to wrap it up. Do we have any questions? Do we have time for questions? Yes. We can have time for 3 questions. Thank you very much for a very interesting presentation. Can you maybe befriend SODR with Grafana? Answer: you don't really need to monitor here. We need a system which receives alerts and forms some tickets. We need a ticket system. Because ODR, basically as a source of telemetry, then it makes sense to make it more casual to work with the events. Or maybe it will be a system which will create incidents, some kind of RP. Question: yeah, can you befriend it with ELK, for example? Answer: yes, you can befriend anything with ELK. Question: so this is provisioned, this is a possibility, is this correct? Answer: sure, they could have this. We actually did this with help, and it worked. Question: you detect the shell in the query, as far as I can understand. Did you want to try to check the reply instead of request? Answer: you mean the HTTP request? Answer: no, it's not about the HTTP, it's about RAM designation. Question: but when it arrives, still it's in the request? Answer: yes, it is in the request. Okay, let me put this differently. When we take a look at the agent, we take a look what happens in the memory, what processes are being carried out. Did you want to take a look at the network activity as well? Answer: sure, we had some rules for network activity. We create a profile for normal activity for an application. There are a lot of incoming connection, there are some outgoing connection, and if anything changes, this would be an anomaly. And obviously, you can analyze HTTP, but not necessarily this will be enough. They can be hidden, and I think it's a little bit different. It's a different class of solutions. And maybe one more question. Question: when we speak about vulnerability data classes, is it vulnerability connected more with the bugs and misses by the PHP interpreter, or maybe it's connected with some peculiarities of implementation of the web application itself? Answer: Daniel had a great research. It's a bug inside the PHP nucleus, which is order 7.4. It's about the interpreter. Yes, it's about the interpreter. It works. You can just take it and use it. Thank you very much for your attention. And we have to conclude, and we will continue during the next conference.